Chapter 2.5 is on the transformation of functions. These are our objectives we're going to cover. I'll let you read those on your own. Let's start off by talking about the 7 common functions. We're going to go through the characteristics of each. F of x equal to c is known as the constant function. It has a domain of all real numbers. The range is just c. The function is constant on the entire real plane, and the function is even. So let's recall that the domain is referring to the x values, and the range is referring to the y values. So all x values are included since this is a horizontal line that goes through the point y equals c. And the range includes only c because that's the only y value, c. This piece right here, being constant and even, is added information that's not really important but useful for you to know. The next one is f of x equals x. Again, his domain is the entire real line. His range is the entire real line. He is increasing on the entire real line, and he is odd. F of x equal to absolute value of x has a domain of all real numbers. The range only includes 0 and positive numbers, because recall when you take the absolute value of something you get out positive or 0. So that's why this bracket means to include. The function is decreasing on negative infinity to 0 and increasing on 0 to infinity. So it's falling and then rising. And the function is even. F of x equal to x squared is your parabola, or your quadratic. Its domain consists of all real numbers. This range consists of 0 and positive numbers, because when you take the square of anything, you get back a positive or 0. The function is decreasing on negative infinity to 0 and increasing on 0 to infinity. And the function is even. F of x equal to the square root of x has a domain of 0 to infinity, includes a 0, because again it's a square root, it's the principal square root. Which means you only get positive, or how about this, non-negative values. So you can get 0 as well as positive numbers, but you'll never get a negative value out of it, which makes its range also 0 to infinity. So you cannot take the square root of negatives, and when you take the square root, the principal square root, you get positive numbers back, including 0. The function is increasing on 0 to infinity. The function is neither even nor odd. And then we move over to the standard cube function, so x cubed has a domain of all real numbers. The range includes all reals. It's increasing on the entire real plane, and the function is odd. And then we have our cube function, cubic. The cube root of x. The domain includes all reals. The range includes all reals. It's increasing on the entire real line, and the function is odd. Alright, so now that we have had a, what would you call it? So now that we have looked at the 7 common functions, let's talk about our transformations. So a vertical shift. So if f is a function and c is a positive real number, the graph y equal to f of x plus c is the graph of y equals f of x shifted c units vertically upwards. So notice that you're making a change on the function. Originally you would just have f of x, but now you're adding c to it. So you're making a change on f of x, who is really y. So you're making a change on the y-axis or the y coordinate. Okay, so let's say it that way. You're making a change on the y coordinate. I don't know how to spell coordinate. So I'm going to say the y, I'm going to say y coordinate just like that. So remember, you have a point, x comma y, and the only piece you're changing is the y, and you're changing it by doing what? You're going to shift c units up. So you're going to move c units upward. And then if you were subtracting c, you would change the y coordinate by moving c units downward. That would make it a vertical shift. So let's hear his example. We're going to use the graph of f of x equals the absolute value of x to obtain the graph of g of x equals the absolute value of x plus 3. So this is the graph of just f of x equals absolute value of x. Let's go back. Now notice that this right here, this absolute value of x, if I wanted to rewrite this entire thing, well, g of x will now become f of x plus 3. Because remember, the absolute value of x is the same as saying f of x from right here. So you're changing the function by adding 3, which means you should shift up 3 units. So we're going to shift up 3 units. So here's a point, and its point is 0, 0, correct? If I shift the y part up 3, it will become 0, 3. So 1, 2, 3. And you would do the same with the other points. So like here is 0, 1. So if I move it up, here is 1, 1. So if I move it up, it will become 1, 4, and etc. So the graph in red is g of x, and the graph in blue is f of x. Alright, now let's talk about horizontal shifts. So again, if we have f as a function and c as a positive real number, then by making a change on x, you are shifting the graph to the left or to the right depending on your change. So this is always the opposite. If you are adding c to x, then you're really going to move the x coordinate to the left c units. So the x coordinate changes by moving c units to the left. It's just the opposite, okay? So if I'm adding c, I'm really moving it to the left. And if I am subtracting c on x, then the x coordinate changes by moving c units to the right. Okay? Move c units to the right. It's always the opposite with the x's. If you make a change on x, you must do the opposite. This is saying add c, so the opposite will go to the left. This is saying subtract c, so the opposite says go to the right. Alright, here's an example. So we're going to use the graph f of x equals the square root of x to obtain a graph of f of x equals the square root of x minus 4. Alright, so notice that we have a change inside the square root on x. Instead of it just saying x by himself, now we are subtracting 4. So we're subtracting 4, and since the change on x, we must do the opposite, which means we must go to the right 4. Remember, right is like saying positive, and that's the opposite of subtracting. So move right 4 units. So here's the point 0, 0. And if we move to the right 4 units, it would become the point 4, 0. So 1, 2, 4, 0. And then you would do the same with the other points. Think of them as moving as well. So 1, 2, 3, 4. And the red graph represents g of x, and the blue is f of x. Alright, so now let's talk about reflections. So if we reflect about the x-axis, so if we have the graph y equals to negative f of x, the graph y equals negative f of x is a graph of y equals f of x reflected about the x-axis. If we reflect about the y-axis, the graph y equals f of negative x is the graph of y equals f of x reflected about the y-axis. Notice the difference between them. If you have a negative on the outside of your function, so you are putting a negative on the y. Yes, because remember, f of x is the same as saying y. So you just made your y negative. So let's go ahead and get our x and y plane up here. This is my x-axis. This is my y-axis. And if I have a graph and I just made my y negative, so let's pretend like I was in a graph and it was up here. So for example, maybe something like this. Let's say my graph was up here. I'm in the first quadrant. And let's say I had it look like this and I had the negative in front of f of x. Well, it's telling me to make the y negative. So let me change. It's telling me to make the y negative, which means I will reflect it over the x-axis down here where the y is negative. Let's look at the other reflection. So again, let's use the same example. I'm over here in the first quadrant, and this time the negative is inside the function on x. So I'm changing x, I'm making x negative. So over here x was positive, where is his opposite, where is his negative? Over in the second quadrant, which means you reflect it over the y-axis. Y-axis. So if you have the negative on x, you flip it over the y-axis. Do the opposite. This is positive x, this is negative x over here. If you have the negative on the outside of the function, then you're reflecting over the x-axis. This is the positive y up here, or f of x. And this is the negative y down here, or negative f of x. Alright, let's do an example. So we're going to use f of x equal to the cube root of x to obtain a graph of the cube root of negative x. Okay, well, first of all, we go ahead and notice that we have the negative on x, which means, well, we're going to reflect this about the x-axis. Now, I actually find this problem to be interesting. Because even though, let's do it this way, the negative is on x, which means x, if I start over here in the first quadrant, all of these are the positive x, right? If I have the negative on x, I must do the opposite, which means these pieces, these points over here, must use the negative x. And it's a mirror image, right? So if he's going like this way, I must go this way. The opposite way, but they must be the same. These include the negative x's. Well, down here I am in the third quadrant. And over here in the third quadrant, I already have negative x's, which means if I put a negative on it, now it becomes positive. So I'm over here in the positive x's. And that's reflecting it about the y-axis. So notice that with this problem, you actually can reflect it about both axes. It looks exactly the same. If I reflect it over the x-axis, it still matches up. And that's only because this is a cube root. You could say the negative is on x, or you could factor the negative out. And you can say the negative is actually on the function. Both works. Alright, so now let's talk about vertically stretching and shrinking our graph. So again, f of x is our function and c is a positive real number. When c is greater than 1, if c is greater than 1, the graph of y equals c times f of x is the graph of y equals f of x vertically stretched by multiplying each of the y coordinates by c. And if c is in between 0 and 1, you still multiply each of the y coordinates by c. The graph would just look like it's vertically shrunk, but the steps are still the same. So if I have a constant multiplying on my function, so this constant is multiplying f of x, regardless if he's greater than 1 or between 0 and 1, we do the transformation by multiplying the y coordinates just by c. So here's a graph, and it says use the graph of f of x equal to the absolute value of x to obtain a graph of g of x equal to 2 times the absolute value of x. Well, to do this, the first thing we're going to do is get some points. So this point, well, the first thing you should do is graph the common function. Okay, so graph the common function, which they did for us. And then the second thing is go ahead and pick some points. So we want to pick points that are off this graph. So I had 0, 0. What about 1, 1, and negative 1, 1? So even though you can't see the points on here, we can assume those are the points because this is the absolute value of x. And the absolute value of 1 is 1. And the absolute value of negative 1 is 1. So then the next thing you want to do is perform the transformation on the points. Okay, so we are taking the absolute value of x and multiplying by 2, which means we are changing the function. Because this is the same as saying 2 times the absolute value of x. All you do is make the change. So we're multiplying the function by 2, which means we're making a change on y. So we're going to take each of the y coordinates and multiply it by the 2. So 0, 0 has just become 0, 0 still. 1, 1 becomes 1, 2. And negative 1, 1 becomes negative 1, 2. And then we graph. So 0, 0 still here. 1, 2. And negative 1, 2. Okay, that's the best I can do. Alright, so the graph in red is g of x, and the graph in blue is f of x. Now let's talk about horizontally stretching and shrinking our graphs. So again, same setup, except for now we're taking f of x, y equals f of x. Y equals f of c times x. So this time we're multiplying the x by c. So we're making the change on the x. So it says if if c is greater than 1, the graph of y equals f of x c times, let's start over. If c is greater than 1, the graph of y equals f of c times x is the graph of y equals f of x horizontally shrunk by dividing, this time is dividing, each of the x coordinates by c. And the same thing here. If c is between 0 and 1 and we are making a change on x, then we're still going to divide each of the x coordinates by c, except for now our graph is going to horizontally stretch. So if it's a change on C, if we are multiplying, if it's a change on X, if we're multiplying X by a constant, its transformation will be dividing each of its X coordinates by C. Alright, so now let us practice doing a complete transformation. So the first thing we're going to do, we're going to use the graph f of x equals to x squared to obtain the graph of g of x equals negative parentheses x plus 1 whole thing squared minus 2. And it's very important that you do these in the correct order. So the first thing you want to notice that we're starting with the graph f of x equals x squared. So the first thing you should do is graph f of x equal to x squared, which they did. And then the second thing, well, what is the first transformation? Well, notice inside the parentheses, what changes? Instead of having an x squared, is x plus 1 squared. So we made a change on x first. And since we're adding 1, we're really going to move or shift the graph 1 unit to the left. Remember, if it's a change on x, you do the opposite. It's telling me to add 1, so I really go 1 unit to the left. So we're going to take this point, and we're going to shift it. So it was 0, 0, now it becomes negative 1, 0. This one was 1, 1, now it becomes 0, 1, and etc. Just shift over 1 unit. So that's the first transformation. Then we move on down to the third step. So now the next thing we notice, well, now we have a negative on the outside. We have a negative on the outside of x squared. It's not inside on the x, it's on the outside, which means I am changing the function. If you absolutely do not see anything different on x, it's on the function. So for example here, we are adding 1 to x. That was an absolute change on x. So it was on x. This negative isn't touching x at all. It's on the outside of the parentheses, which means you assume it's on the function, which means you need to change the function. So having a negative on the outside means we're changing the y, which means we're going to reflect it over the x-axis. So instead of being up here, now it's down there. All it is a reflection. And remember, the best way to remember it is I have a negative on the function, which means it's the y. So all of these were positive y's. Now they need to be negative y's by just flipping it. And that's a reflection over the x-axis. So we reflect it over the x-axis. And then the last step is take care of this minus 2. This minus 2 came out of nowhere. And again, realize it's not a change on x, which means it's a change on your function. And when it's a change on your function and it's shifting, you follow it correct. You follow it exactly. So it says subtract 2. So we would shift the graph 2 units down. So instead of it, so instead of this point being here, I will come down 2. So 1, 2. And the same if these matched up, right? So he should have really been here. So 1, 2, and continue. So hopefully if you got it correctly, your graph should look something like this. Alright, so now let us talk about using your graphing calculators to graph. This thing has changed on us. It did. Alright, so the first thing we want to do, in your calculators, you should have the TI 83 or 84 models, the graphing calculators. At the top, you should see a button. at the top you should see a button and it says y equals. If you can't see it on my screen, I can't zoom in right now. So go ahead and just trust me. It's the very top button. It says y equals. Go ahead and press it. And then you would want to type in your function. So for example, let's type in the function we just graphed. So let's type in negative parentheses x plus 1 close parentheses squared minus 2. Your square key is right here. It says x squared. How do you type an x into the calculator? You use this button. It has x, t, and tau on it. So hit y equals. Now you want to type in your function. It says negative. The negative key is down here. Hit negative, then parentheses. He's right here. X plus 1, so plus 1, close parentheses right there, square it, and then minus 2. Now, let's go ahead and adjust your windows. Where's my calculator? Let's adjust your window. So next to your y equals is your window button. Go ahead and press your window button. Your window should have a default with an x min of -10, an x max of 10. The x scale is going to be 1. That's basically how you undo your tick marks. Your y min is -10. Your y max is 10. And again, your y scale is 1. Once you have that set up, go ahead and hit graph. And you should see the graph of the function we just did. And it should match, correct? And if you wanted to zoom in to see further, there's a zoom button next to your window. It's right here. Hit zoom. And then you can scroll down to highlight number 2. It says zoom in, and then you can hit enter. And of course, you can place the cursor wherever you want. So if you just move your buttons over and up and down, you will see your cursor moving. So I'm talking about these buttons right here. You can control your cursor that way. Once you have the point you want to zoom in at, hit enter, and it will zoom in your graph for you. And of course, if you want to change it, you go back to window and you adjust your window once more. Alright, so this will conclude the video for 2.5. Please let me know if you have any questions.